Biomimicry is the practice of learning from and emulating nature. And we do this by finding the inspiring organism or ecosystem and distilling from that the principle that we wish to copy. Now, what's really interesting is that there are some generic principles that you find in just about every organism and ecosystem on the planet. They're repeated strategies or repeated patterns. And because every single organism and ecosystem on the planet has these principles, it's pretty certain that they are the winning strategies for surviving and thriving on this planet. These are what we call life's principles. And they are the strategies that all of life exhibits. And the idea behind learning life's principles is to consider how we can integrate these principles into our designs. The best way to understand the relevance of life's principles is to take you through an example. I'm going to begin by giving you a human design and then compare that to the equivalent in the natural world. So think about a solar panel. It's really good at integrating some ecological principles. It's making use of readily available, renewable, abundant solar energy, and it's very efficient. But it's only designed for energy, and it's not designed with the whole system in mind. In fact, when it's made, it uses pretty toxic chemistry, and it uses a heck of a lot of energy, usually fossil fuel based, emitting large amounts of carbon. And when its life is over, it ends up in a landfill. It's not biodegradable and can cause some bleaching. Now compare that to nature's solar panel, a leaf. It breathes in carbon dioxide and breathes out oxygen while it's manufacturing this material that both captures the energy of the sun and stores it. It is so life-friendly that you can eat it. At the same time, while balancing the cocktail of gases to sustain life, it's also driven by evapotranspiration, which drives the rain and contributes to the water cycle. And when its life is over, it falls to the ground, turning into compost and building soil through a cooperative relationship with the fungus and the worms and the bacteria on the ground. If you zoom into this leaf, you'll see the distributed pattern of the veins is very similar to the distributed patterns of the branching of a tree, or the branching of your lungs and the branching of your veins. And even if you flew up into the sky and could see river systems, it's the same branching pattern. It is in fact the lowest energy pathway, mathematically, to move a fluid from a point to an area, and vice versa. It also provides a very resilient system for distributing water, for distributing materials, and for distributing energy. If a caterpillar was to eat any part of this leaf, you could still distribute the nutrients across the entire leaf. There's not just one leaf, one centralized energy supply for the entire tree. There's a distributed, large number, redundant number of leaves on the tree. And there's not just one type of tree. There's a diversity of trees with a diversity of types of leaves to respond to different contexts and be locally attuned and responsive. There's not just one type of leaf in the forest. There's so many different types, not only in shape, but in structure as well. And even if you feel the materials are either waxy and thick or thin and flexible. And each one has a different way of meeting the function of capturing energy, but in different contexts and able to respond to different contexts. When the leaves fall to the ground, they don't only build soil, they also insulate the ground, ensuring that the moisture levels and the temperature are regulated over the different seasons. If you zoom into the ground, you see this interconnected network of roots and fungus that cooperate together to exchange nutrients, while at the same time holding the soil and forming a sponge-like function to hold the water as well. In the seed, it's like a little USB, and there is a digital blueprint for 3D printing in another entire plant. And this seed can fall anywhere in the local environment and gather towards it the abundant materials readily available using only the energy of the sun to 3D print, build from the bottom up, and another entire energy system altogether. This time better evolved to fit within the local context. If you can imagine, we could redesign our solar panels to think about the entire system by taking into account each of these principles. We are beginning to do that, and there's many examples in biomimicry on how we can achieve just that. But we can also apply life's principles for the design of our entire energy system. We can apply it to the design of any product, process, or system at all. And they offer us a very clear guiding framework on how to consider the entire system while creating conditions conducive to life and being resilient at the same time.